Good evening, everybody. Tonight, I'm going to cover basically practice for the CSWA. We've more or less learned all the tools you need to know at this point for the CSWA. So we didn't spend too much time on drawings or assemblies. Hopefully you guys have been practicing assemblies. There's plenty of problems in the book that we didn't do that are great practice. Be ready to kind of do some more complicated assemblies, not necessarily the simple ones we did in the very beginning of learning assemblies. But so this video is going to cover just a couple of the tools that I haven't shown you guys yet that you absolutely need to know for the CSWA. Without these tools, guaranteed you're going to fail it because you won't know how to actually answer the questions. You might be able to make the model, but you're not turning in the model. They want to know, okay, if this model you made was made out of some sort of steel, how much is that part going to weigh? And based on the weight, they'll be able to tell if you modeled it right. If you have any dimensions off, the weight's going to be different than what the answer is, and then you'll get it wrong. So if you don't know how to find the weight of this part, or how to find the center of mass of an assembly, or how to measure a couple things for an assembly, you're going to fail. I'm going to be completely honest. Without knowing those things, you don't stand a chance on the CSWA. So please watch this video. There's also a little bit of explanation in the book as to how to do this, but this video is going to be the best way for you to learn that. So I've assigned the 4 models that they give you in chapter 21. Those are due for homework. What I'm not requiring for homework, but I highly recommend you do, are the drafting competency questions in the beginning. Just multiple choice. It asks you about different views and what kind of view it is. So answer those questions and check them yourself. And then the assemblies, there's 2 assemblies at the end. They're pretty long portions of the chapter. Those are going to be the best practice you can do for practicing for the assemblies on the CSWA, but I'm not requiring them just because I'm simply giving you so much. Parts are going to be the bulk of the test. Assemblies will be the second biggest portion of the CSWA, and then the drafting competencies will be a smaller portion. I'm going to make a second video later explaining how to find another practice exam for the CSWA, and this is going to allow you to actually use the real testing module. So that'll be great practice as well if you have time. That's not going to be required, but for anybody that's serious about passing the CSWA, it'd be a little silly to skip trying the real practice test. That's going to give you the best idea of what the test is going to be like, how difficult it's going to be, how to actually use the testing module. If you know how to use it ahead of time, it'll save you a little bit of time on the real exam. So please check out that video too and try that exam. It's going to be a lot to do in these last couple weeks, but this is kind of the crunch time. This is where you need to start really studying. We got 3 weeks till we take that. Well, 3 full weeks till we take that. So please try those things out. Give me 1 second here. I just need a sip of water. All right. So these new tools. The first one that you're going to see is mainly for parts. I've just got a little piece of something I was working on here at work. I'm building a hoist. This is just a brace for the hoist. But so here's your part. First thing you need to do to find the weight is first we need to tell SolidWorks what material this is made out of. So on your design tree over here, we have this material not specified. You can see next to it. Button on the design tree. So if you right click on that and at the very top click edit material, and this is where you'll select the material that they tell you to use on the CSWA. So it could be anything, but keep in mind this list is long. There's a folder up here. We're in the steel folder right now. If I minimize that, there's iron, aluminum alloys, copper alloys, titanium, zinc, blah, blah. So the list goes on and on. There are a ton of materials in here. We'll just work with steel. I don't know. We use a lot of 4340 at work, so I'll select that one just for the heck of it. Sorry, my screen's flashing again here. I don't know. I've had an issue with this. If sometimes the names are a little confusing compared to what they actually told you on the exam. So what you can do here is once you select the material, they should in the exam tell you what the density of that material is. So look at the density here and see if it matches what they have in the book. If the densities match, you're good, because that's going to give you an accurate weight based on the dimensions of your part. If your units on here don't match the units in the book, hop on Google and do a quick little conversion real quick. This is in kilograms meter cubed. You may see it in pounds cubic inches, I don't know, something different. But if you need to convert it, just use Google. That'll be a quick way to just check and make sure you have the right density. The density of your material is highly important to getting the correct answer. So anyway, I've got 4340 annealed steel selected here. We'll click apply and close that. You can see here on my design tree now, it says 4340 steel annealed. You even change the color, okay? So then, once you have the right material set, here's a tab we haven't quite touched on it. Maybe a few of you have, but we've used the features tab, the sketch tab. Now we're going to use the evaluate tab. Select evaluate, go up here to mass properties, the big button, click mass properties, and that's where you're going to find your answer. So here it tells you the density, which we already knew because we looked at it when we selected it. But you can see here this is in pounds per cubic inch instead of what we saw in the properties, which was kilograms meters cubed. So we've got our density there. We can see our mass clearly right there, 1.168 pounds. We can see the volume, which you won't need. We can see the center of mass. Center of mass is going to be used for assemblies, and that's going to be a big one. The reason I say that is because when you do assemblies, you need to pay very, very, very close attention to where they tell you to start your part. You want to make sure it's on the right plane. Make sure if they want the right side of something mated to the front plane, you make sure you do that. Make sure you start your assembly oriented the exact way they want in space. That way, when you go to submit your answer, which is the center of mass, it's correct. If you do it turned 90 degrees of what they wanted, you're going to have the completely wrong answer for the center of mass. So it's highly important on assemblies you start how they want. So anyway, that's these mass properties again. Up here on the evaluate tab, just the big button that says mass properties. That's where you can find the mass of a part after you've set the material, and you can also find the center of mass, and that's what's going to be really important. I'll switch over here to say an assembly. Here's that hoist I've been working on for work, fun little assembly. You can go to McMaster.com and download a lot of these things. That's where I got these trolleys from. So you can see how everything on my hoist moves here. This will actually swivel too. You can see that rotate up. It's on pins. But anyway, here's the assembly. So then for an assembly, same thing on the evaluate tab. Select mass properties. I don't have my material set for this. It actually should be based on the parts. So let's check. Yeah, it's based on the parts themselves. So anyway, it says my mass for this whole hoist system here. It's like 11 feet by 6 feet by 10 feet or something. It's 8 pounds. But there's my center of mass, and that's highly important. Again, it's based on how I started it and which way this is facing in space. And they may ask you to submit the X, Y, and Z coordinates for that. You can see here if I turn my planes on. Nope, I guess it's not going to show me them. Let's see. There we go. But you can see all the planes. There's my top, my right plane, my front plane. And so it really is important for an assembly on the test where you actually have these positions. So my foot on here is up against right up against the front plane. But they may want it this way, facing 90 degrees the other way, and that's going to totally change your center of mass. So I can't beat that to death enough. Make sure you orient it in space exactly how they want. Very, very important. Don't forget, if you need to if you insert a part into an assembly and it mates, the first part goes in a way you don't want, if you right click on that part and you go to float, now that part can move off of being stuck where it is, and you can remate it to different planes. Select this side, mate it to the right plane over here, so it'll turn at 90 degrees. And then you can mate this surface to the top plane and mate this surface to the front plane, and then it's locked in space again, but it's turned 90 degrees to how it is right now. So that's how you can change which direction it's facing. Just right click on it, click float. Where'd it go? Did it not? Oh, it's still floating from when I did it. I tried to undo it. Anyway, so that's how you can float it and then change the orientation or what planes it's mated to. Remember, when you're in mate, you can drop down your design tree here and actually select planes to mate things to. So that's that. Let's jump back over to that part that I had. The other tool you might be asked to use in assemblies is the mass property, or sorry, the measure tool. Actually, let's go back to the assembly for that. A little more exciting that way. I'm going to turn off the view of my planes. I don't want to see those right now. So the measure tool, we'll select that here. You can see this box. Whatever is in this box is what it's measuring between. So let's say I wanted to know the distance between this pole and the outside of this pole. I'm going to click the surface here. You can see it highlight in green. You can see it pop up in the box here. And you can see some properties about that. I'm going to zoom out a little here and rotate to the other side and select the other pole. And it's going to tell me the distance between them, 80 inches. So from outside to outside, this is 80 inches. You could do more complicated things like, say, let me just show you. They won't make you do this, but I just want you to see how this works. If I can get it to select the right surface. I'm going to select that surface there. And I'm going to select, let's say, the outside of this foot here. Should be 82, 81, I mean. So you can see here we've got a bunch of different measurements going on. My normal distance, which is going to be perpendicular to the surfaces, is 81 inches. The reason it's 81 and not 80 is because this foot sticks out 1 inch more than this leg did when we originally measured it. So that's how I get 81, and that's from surface to surface perpendicularly. You can see here between those surfaces, the height too, it shows you 132. You can see the actual distance between the 2 points I selected is 154.871. And it'll show you a couple other things. Here's our distance in the X direction, which is the same as the normal direction, and that's 81. So if you see a bunch of these, that's just how you would interpret them. Just take your time. You can move them out of your way if you need to, and understand what they're meaning. Y direction, X direction, normal, which is the same as X, and then the actual distance from the exact points that I clicked. Okay, so that's the measure tool. Make sure you practice with that. They may ask you some questions in assemblies that want to, once you mate things in a certain orientation in an assembly, they may want to know the exact distance between things that are set at different angles or all kinds of fun things. So those are the main things you need to know on how to answer the questions. Know how to set the material, know how to find the mass, know how to find the center of mass, and know how to measure things, okay? So those are the big ones. That's the new stuff. Once you guys turn in this homework next week, I will post videos on how to complete the part files. I'll try to post videos on how to do the assemblies as well. And then later on, I'm going to post a video on how to do or how to find the other practice CSWA exam. And that one's going to be way even better than the one in the book. This one in the book is good, but that one's going to be just like the exam. It's a half-size test taken from an old CSWA exam that they used to give. So that'll be great practice. Anyway, hope this helps. If you guys have any questions, please feel free to reach out. I'm always available to help, mostly on Wednesdays, but I can try and set up video calls other days of the week to help you guys or whatever you need. Just let me know. Hope you guys have a good night.